Counting Principles, Chapter 10, Section 8. In this unit, we're going to learn to find the number of possible outcomes in an experiment. You have 3 vocabulary words: fundamental counting principle, tree diagram, and addition counting principle. These can be found in the glossary of your book. That's probably the best place to look, although we'll talk about them here. The fundamental counting principle. If there are m ways to choose a first item and n ways to choose a second item after the first item has been chosen, then there are m times n ways to choose all the items. That is actually the definition, and we're going to show you how that works. Open to example 1 in your notebook, and let's look at it. License plates are being produced that have a single letter followed by 3 digits. All license plates are equally likely. So we're going to find the number of possible license plate, and we're going to use the fundamental counting principle. So first we have a letter choice. In this letter we have 26 choices because there are 26 choices in our alphabet. Now the first digit, there are 10 choices. You can have the number 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are 10 digits. For the second digit, we have an additional 10 choices because it can be the same thing. So we have the options of 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And likewise for the third digit. Same 10 choices. So the number of possibilities is 26 times 10 times 10 times 10, which is 26,000. So the number of possible one-letter, 3-digit license plate is 26,000. Example 1b. We're going to find the probability that a license plate has the letter Q. Well, referring back to the first part of this, we know that the letter Q is one alphabet, one letter, out of a possible 26 letters. Okay. And then for numbers, we have the numbers possibility of 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. There's 10 digits possible. So 10 digits, 10 digits, 10 digits. Likewise, 10 digits, 10 digits, 10 digits. So the only real change is this one. We're limiting, what we want is limiting the first digit to Q. So the numerator is going to be 1,000. I multiplied those together. And the denominator is 26,000. Now, if you divide the top and bottom by 1,000, you get 1 over 26. So 1 over 26 is a probability that a license plate has the letter Q. And that's approximately 0.038, that's 38 thousandths chance, or 3.8% chance. Example 1c. Let's use that same information and find the probability the license plate does not contain a 3. So we know that there are 9 choices for any digit except 3, because there's 10 choices total. But without a 3, we're looking at 0, 1, 2, 4, 5, 6, 7, 8, and 9. And you'll see there's 9 choices. So it can have any one of the 26 letters. It can have 9 choices for the first digit, 9 choices for the second digit, and 9 choices for the third digit. So there is, when you multiply these 4 numbers together, 18,954 possible license plates without the letter 3. So the probability of not having a 3 is what you want, or what's possible. Well, what we want is 54 options out of the 26,000 possible. Divide that out, 729 thousandths, which equals 72.9% chance of not getting that, not having a 3. The fundamental counting principle tells you only the number of outcomes in some experiments, not what they are. To do that, you need to use a tree diagram. That is one way to show all the possible outcomes. So let's look at using a tree diagram. You have a photo that you want to mat and frame. You can choose from a blue, purple, red or green mat, and a metal or wood frame. Describe all the ways you could frame this photo with one mat and one frame. Well, you could find all these possible outcomes by making a tree diagram. Okay. Now to decide this, we can count how many there should be. If you look at this, we have 4 options here. So this is a 4. 4 options in yellow. And then we have 2 options here. 2 options there. So when we multiply them together, 4 times 2, we realize there are 8 different ways to frame the photo. And we can make a tree diagram, that's what this is, to show that. Each branch of the tree diagram represents a different way to frame the photo. The way shown in the branches could be written as. Okay, so we got blue, metal. We go blue and metal. We could go blue and wood. We could go purple and metal. And purple and wood. We can go red and metal. You should see a pattern here. And red and wood. Green and metal. And green and wood. And let's count. 1, 2, 3, 4, 5, 6, 7, 8 different options. The table below shows the items available at a farm stand. This is example 3. How many items can you choose from the farm stand? Now we just want to know the number of items. Since none of the list contains identical items, we're going to use the addition counting principle. You know what the addition counting principle is because you looked in the back of the glossary and wrote the definition down. So our total choices is going to be the number of apples plus the number of pears plus the number of squash. So for apples we have 1, 2, 3 possible apples: Macintosh, Red Delicious, and Golden Delicious. For pears we have 3 pears: Busk, Yellow Bartlett, and Red Bartlett. And for squash we have 2 options: Acorn and Hubbard. So we realize that 3 plus 3 plus 2 means we have 8 different choices, and that's our solution. That's how we use the addition counting principle. Any questions? If so, bring them to class tomorrow and we'll talk about them then.